Hey guys, it's Mrs. Thomas. Today I'm going to teach you how to solve a distance rate time problem using a linear equation in ALEKS. This is the famous two trains type of problem. This type of problem pops up a lot on different thinking challenges. So two trains leave stations 288 miles apart at the same time and travel toward each other. One train travels at 85 miles per hour, while the other travels at 75 miles per hour. How long will it take for the two trains to meet? Do not do any rounding. So, um, obviously by the title of the section that we're talking about, we're using distance rate time formula, which is distance equals rate times time. So in this case, the trains are 288 miles apart, and we know that the time that they are going to travel is the same because the two trains meeting, that means they've traveled the same amount of time. So that we have to think about. If we think about the trains individually first, my first train would travel 85 miles per hour, so that would be its rate. So the distance, the whole distance from that first train to get to the second train would be 288 equals 85 times the amount of time. For the second train, so this is train 1, train 2, if it were the only one traveling, it would also travel 288 miles, and that would be 75 times t. So most people start here, and then they get a little bit stuck because they don't know what to do. So here's the problem that isn't always obvious to everybody. This distance is not 288 for these trains. In fact, we don't know how far along the path train 1 has traveled when it meets train 2, but we do know that the time is the same. So what we have to do is we have to say, okay, I actually don't know this 288, so I'm going to make train 1's distance x. If train 1's distance is x is going to be 85t. Now, if train 1 has traveled a distance of x and the total distance between them is 288, then that means that when train 2 is traveling, it's going to travel whatever is left in that 288 after the x. So this, for train 2, its distance becomes 288 minus x. Now, this has an x in it, which we know what x is equal to. X is equal to 85t. So now I have, by putting in this 85t, which is the same thing as x, now I have written a linear equation in order to solve and figure out my value here. So if I want to solve for t, because time is what I'm looking for, how long will it take? That means I'm going to add 85t on both sides. So this gives me 10, carry the 1, that gives me 160. So 288 equals 160t. And so then we would divide, and that would give us 288 over 160. Now, it says not to do any rounding, which means that typically when they say not to round, they want you to leave it as a fraction. So I would work to reduce this, and if you're not using a calculator, of course, it'll take a little longer to reduce, but I know for sure because both of these are even that it is all divisible by 2. Then I look at that and say, oh, well, that's definitely divisible by 2 again, divisible by 2 again, again divisible by 2, and finally one more time divisible by 2. So maybe they want you to write 9/5 or 1 and 4/5 since the unit was hours. 1 and 4/5 hours. But this comes out evenly without rounding. This is, 4/5 is 8/10, which is 0.8. So that really isn't rounding because you haven't changed anything. It comes out to exactly 1.8. All right, hope that helps you out with the 2 train problems.